MS Ramaiah University of Applied Sciences.
Hello students, let us have a discussion on Clipper circuits. The aim of this experiment are to observe waveforms at the output of shunt and series clipper circuits and to find the positive and negative clipping levels. Motivation to this experiment are: wave shaping operation performed by clipping circuits are required in all communication systems to ensure noise-free reception of signals. Clipping circuits are employed to limit noise in FM, AM, television and radar receivers. Separation of picture signals from synchronizing signals in television receivers is done with clipping circuits. Let us understand the theory behind the experiment before conducting it. In electronics, a clipper is a circuit designed to prevent the output of a circuit from exceeding a predetermined voltage level without distorting the remaining part of the applied waveform. A clipping circuit consists of linear elements like resistors and non-linear elements like junction diodes or transistors, but it does not contain energy storage elements like capacitors. Clipping circuits are used to transmit part of a signal waveform which lies above or below a certain reference voltage level. Thus, a clipper circuit can remove certain portions of an arbitrary waveform near the positive or negative peaks. Figure shows the circuit diagram and experimental setup of a positive shunt clipper with input and output waveforms. Construct the given circuit diagram for positive clipper on breadboard. Oscilloscope and function generator is connected to the breadboard using probes. Set an input signal in sine wave form of 1 kHz frequency and 8 volt peak-to-peak amplitude in the function generator. Apply this signal as input. Measure the input and output from digital oscilloscope. Measure the clipping level at the positive side of output signal. Figure shows the circuit diagram and experimental setup of a negative shunt clipper with input and output waveforms. Construct the given circuit diagram for negative clipper on breadboard. Oscilloscope and function generator is connected to the breadboard using probes. Set an input signal in sine wave form of 1 kHz frequency and 8 volt peak-to-peak amplitude in the function generator. Apply this signal as input. Measure the input and output from digital oscilloscope. Measure the clipping level at the negative side of output signal. Figure shows the circuit diagram and experimental setup of a positive series clipper with input and output waveforms. Here, the diode and load resistor are connected in series. Repeat the above procedure and measure the clipping level from digital oscilloscope. Limitation of the setup is: we cannot apply DC power supply more than 15 volt as dual DC power supply available in lab has its maximum range of 15 volt.
Hello students, experiment name is Clipper circuits. Aim of the experiment is to observe the output waveform at a positive shunt clipper circuit, output waveform at a negative shunt clipper circuit, output waveform at a positive series clipper circuit. Components used for the circuits are digital oscilloscope, dual DC power supply, function generator, diode, resistor, probes, breadboard and connecting wires. Before starting the connections, let us see about the different components used for the experiment. This is function generator. It is used to apply AC signal to any circuit. This is dual DC power supply. It is used to apply DC voltage to any circuit. This is digital oscilloscope. It is used to observe the waveform of any circuit at any point. In this experiment, we are using this to observe the input and output waveform. These are the connecting wires. These wires are used to connect the different components on a breadboard, and these are the probes which are used to connect the different components in a breadboard to a function generator as well as to a digital oscilloscope. This is breadboard on which we are connecting the different components together. This is the diode which you are using in a circuit for a clipping. This is a resistor having a value of 3.3 kilo ohm. It is used to limit the current in a circuit. Let us begin with the circuit connections. Positive shunt clipper circuit connections. This is a probe. I will connect to a function generator, and this function generator acts as a input voltage to the clipper circuit. This is the positive terminal of a input voltage, that is V in. This is connected to the resistor one end. I will connect resistor in a breadboard. Take one wire. I will connect to a positive terminal of a probe which is connected to the resistor one end, and negative terminal of the input voltage is connected to the ground. So, this is negative terminal of input voltage. Let us take the bottom first row of a breadboard as a ground. I will connect to a ground. Now, resistor another end is connected to the diode P terminal. This is a diode, this is a P terminal of the diode. I will connect P terminal of the diode to the resistor, and N terminal of a diode E is connected to the positive terminal of a DC supply. So, I will take a one wire, I will connect to a negative terminal of a diode. This negative terminal of a diode is connected to the positive terminal of a DC voltage source. Then negative terminal of the DC voltage source is connected to the ground. This is the negative terminal of a voltage source which is connected to the ground. So, this first row is a ground, we will connect to a ground. Now, I will connect digital oscilloscope in a circuit. So, I will take a one probe and connect to a first channel of a oscilloscope, and I will take one more probe and I will connect to a second channel of a oscilloscope. If you see the each probe, it has two terminals. This is called negative terminal and this is called the positive terminal. Similarly, the second probe also has two terminal, one is positive, one is negative. So, the first channel probe I will connect to the place where input is connected, that is the positive of the channel 1 is connected to the positive of the input. If you see in a circuit, this is the input positive, I will connect this to the positive of the input, and negative of the channel 1 I will connect to the negative of the input. If you see circuit, this negative of the input is here, which is connected to the ground. I will connect this to the ground. Now, channel 2, again channel 2 has a positive and negative. I will connect channel 2 to the output point, where output is to be observed or measured. So, this is the positive of the second channel which is connected to the P side of a diode. So, this is the P side of a diode in a circuit, and this is the negative of the second channel probe which is connected to the ground. I will connect this to the ground in a breadboard. This completes the circuit connection of a positive sent clipper circuit. Now, let us switch on the equipments which I used here. First, DC dual power supply. Before turning on this equipment, make voltage to minimum value, current to maximum value, then turn on it. Similarly, before turning on the function generator, just check the probe whether it is connected properly or not. Turn on the function generator. Turn on the digital oscilloscope. This is the input voltage which is given to the circuit. So, we need input as sine wave for this circuit. Click on the sine button, and we need a sine wave of 1 kilohertz frequency. So, here we can select a frequency of the signal, click on this button, then set as 1 kilohertz, press on 1, then it will ask the units. We need a kilohertz, so press on kilohertz. Now, we have set a frequency of input voltage as 1 kilohertz and which is sine wave, and also we need to set the amplitude of a input voltage, that is 8 volt peak to peak. So, go to amplitude, press this button and type 8. It will ask the unit of the voltage. We need a peak to peak, so we will select VPP. Now, input voltage has been set as amplitude 8 volt peak to peak, frequency 1 kilohertz which is sine wave. Once input voltage has been set, just turn on the input voltage. According to given circuit diagram, we need a DC power supply voltage of 2.4 volt. So, we will make this voltage as 2.4 volt by using this voltage knob. Increase it. Let us make it as 2.4 volt. Now, we have set a DC voltage as 2.4 volt. Now, this is a digital oscilloscope. Whenever you turn on it, first you have to go for default setup, wait for some time, then go to auto set. Now, we are able to see two waveforms in the oscilloscope. One is input, one is output. As we have connected channel 1 to the input voltage, so the first signal which is having yellow color, which is a input voltage. Since we have connected channel 2 to the output, the light blue color signal is a output voltage which you can read as a second output in the oscilloscope. Now, we will compare input voltage and output voltage. So, to do that, we have to move the signal vertically up and down by using this vertical position knob. So, I am moving the signal 1 to the center, so that the pointer 1 of a signal 1 will merge to this reference axis. Similarly, I will bring the second waveform to the same position, that is, I will merge the pointer 2 to the reference line. Now, I have two signals, one is input, one is output. So, to measure how much is the input voltage and how much is the output voltage, we will just on the input, that can be done by switching off the output, that is button 2. If you press the button 2, signal 2 will be off. Now we can see only the input waveform, and which has its value as 8 volt peak to peak, that we can measure in the oscilloscope. Either we can measure directly or we can change this, that is zoom in. Now if you see this signal is covering 1, 2, 3, 4 blocks from positive peak to negative peak. Yes, this signal is covering 4 block from positive to negative. So this 4 block into the scale of the channel 1, that is 2, 4 block into 2 volts equals to 8 volt, that is the input voltage peak to peak amplitude. Now we will see the output for this given input. Just off the input pressing button 1, now on the output by pressing the button 2. Now this is the output for a given input. To measure this voltage more accurately, I will zoom it by using this knob, and I will move this line to the reference line, that I will move towards left. This can be done by using horizontal position. I will move it towards left. Now if you see this waveform, this is a reference axis like a origin. Below this line it is covering 2 blocks, that is 2 blocks into scale is 2 volt, 2 volt into 2 block is 4 volt, that is it has negative side 4 volt. And if you see the positive side, that is above this line, it is covering 1.5 block, it is covering 1.5 block, 1.5 block into 2 volt, that is 1.5 into 2 volts equals to 3 volt. So we are getting a positive side a voltage of 3 volt, that is a clipping level of this positive clipper circuit. Now we have finished the positive shunt clipper circuit and we have obtained a clipping level of plus 3 volt. Now we will start with the negative shunt clipper circuit connections. If you see the circuit connections of the positive shunt clipper and negative shunt clipper, there is a very small difference, that is there is a diode direction has been reversed and DC voltage source terminals has been reversed. So before doing this, I will turn off the DC dual power supply and I will remove the diode and connect in a reverse direction. Similarly, I will reverse the terminals of a DC source. It can be done like this. So this is a positive which were earlier connected to the P side of the diode, this is a negative which were earlier connected to the ground. Now I will reverse these two terminal, negative I will connect to the P side of a diode and positive I will connect to the ground. Just by reversing the diode direction and voltage terminals, this will be the circuit diagram for a circuit connection for a negative shunt clipper. Now again, before turning on the voltage source DC dual power supply, we will keep voltage to minimum value, current to maximum value, turn on this, and this is a function generator. For this circuit also again we are applying a sine wave as a input voltage with a frequency of 1 kilohertz. Already it has been set as 1 kilohertz frequency, sine wave and 8 volt peak to peak signal, and we need to set DC dual power supply as 2.4 volt, that I will vary from this knob. Let's make this as a 2.4 volt and come to the digital oscilloscope. Again go to default setup, then auto set. Again we can see here two waveforms, one is input, one is output. Again I will merge these two. I will bring the signal 1 to the reference line, similarly signal to the 2 to the reference line, so that I can compare both input and output waveform together. Now we will measure the input voltage as a last circuit. So turn off the second, that is output voltage, by pressing the button 2. Now this is the input voltage. I will measure it how much it is, so I will zoom it. If you see this input voltage, it has above reference line it is covering 2 blocks, below reference line it is covering 2 blocks. So from positive to negative totally it is covering 4 blocks. So 4 blocks into channel 1 scale, that is 2 volt, 4 into 2 equals to 8 volt peak to peak. So the input is having a value 8 volt peak to peak amplitude. So let us check what is the output we are getting for this input. So turn off the input signal by pressing button 1 on the output. So to measure this value, again I will zoom in, I will just zoom out. Now if you see this signal, now the negative side is clipping, negative side we are getting a straight line, it is not a curved structure as a input. So we will measure how much is that. To measure that value, I have to move this signal, this straight line on a reference line. This can be done by using horizontal position. So I will move this signal towards left, so that I can get this flat end of the signal on a reference line. If you see the output waveform, above this 0 line it is covering 2 blocks, each block has a value 2 volt. So 2 into 2 is 4 volt. So output voltage has a positive voltage as plus 4 volt, and negative side, if you see here, negative side the signal is covering only 1.5 blocks, and each block has a value of 2 volt. So if I multiply 1.5 into 2, which is equals to 3 volt, which is the negative clipping level of the circuit. We will note down this reading. This completes the clipper circuits experiment. We have observed and noted the positive clipping level and negative clipping level.
At MSR UAS, we spark your imagination unlike any other.